The 2017 National Electrical Code, or NEC, does not have a specific section dedicated to replacing receptacles on ungrounded circuits. However, the NEC provides general guidelines for replacing electrical equipment within Article 110. Article 110.3b states that listed or labeled equipment must be installed and used according to any instructions included in the listing or labeling. This means that when you're replacing a receptacle on an ungrounded circuit, you must follow the manufacturer's instructions for the specific receptacle you are using. These instructions often provide critical details about proper installation, safety precautions, and compatibility with existing electrical systems. Ignoring these instructions could lead to improper installation, equipment malfunction, or even electrical hazards. Generally, when replacing a receptacle on an ungrounded circuit, the following steps should be followed. Firstly, turn off the power to the circuit of the breaker panel. This is the most important safety precaution to prevent electrical shock. Before you begin any work, confirm that the power is off by using a non-contact voltage tester. Test the receptacle to ensure no voltage is present. Secondly, remove the faceplate from the receptacle. This is usually held in place by 1 or 2 screws. Store the faceplate and screws in a safe place so you can reinstall them later. Thirdly, loosen the screws holding the receptacle in place. These screws are typically located at the top and bottom of the receptacle and secure it to the electrical box. Fourthly, pull the receptacle out of the electrical box. Gently pull the receptacle out to expose the wiring connection. Be careful not to damage the wires or the electrical box. Fifthly, disconnect the wires from the receptacle. Carefully disconnect the wires from the old receptacle. Typically, there are 2 wires connected to a standard receptacle. Take note of which wire goes to which terminal. This is important for connecting the wires to the new receptacle correctly. Sixthly, connect the wires to the new receptacle. Connect the wires to the new receptacle, making sure to match the wiring configuration of the old receptacle. The black wire, which is the hot wire, typically connects to the brass terminal. The white wire, which is the neutral wire, typically connects to the silver terminal. If there is a ground wire, it typically connects to the green terminal. However, in ungrounded circuits, there will not be a ground wire. Seventhly, push the new receptacle into the electrical box. Carefully push the new receptacle back into the electrical box, making sure the wires are neatly tucked inside. Eighthly, tighten the screws holding the receptacle in place. Tighten the screws to secure the new receptacle to the electrical box. Ninthly, install the faceplate. Reinstall the faceplate and tighten the screws. And tenthly, turn on the power to the circuit at the breaker panel. After you have completed the installation, turn the power back on at the breaker panel and test the receptacle to make sure it is working properly. It is crucial to acknowledge that ungrounded circuits are no longer permitted in new construction due to safety concerns. They are, however, found in older homes and buildings. When you are replacing a receptacle on an ungrounded circuit, it is imperative to take precautions to avoid electrical shock. Always turn off the power to the circuit at the breaker panel before beginning any work. Use a non-contact voltage tester to verify that the power is off. Wear appropriate personal protective equipment such as insulated gloves and eye protection. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. Replacing receptacles on ungrounded circuits presents unique safety challenges. Always prioritize safety. Proper grounding is an essential safety feature in modern electrical systems. Grounding provides a low-resistance path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. Ungrounded circuits lack this safety feature, making them more dangerous. When working with ungrounded circuits, it is especially important to take precautions to avoid electrical shock. Consider upgrading ungrounded circuits to grounded circuits. If you are replacing receptacles on ungrounded circuits, it may be a good opportunity to consider upgrading the circuits to grounded circuits. This will improve the safety of the electrical system and bring it up to current code standards. Upgrading to grounded circuits typically involves running a new ground wire from the electrical panel to each receptacle. This can be a complex and costly project, but it is worth it for the added safety. There are specific types of receptacles that can be used on ungrounded circuits as replacements. Ground fault circuit interrupter receptacles, called GFCI receptacles, are designed to protect against electrical shock. They work by monitoring the current flowing through the circuit and tripping the circuit breaker if there is a difference of more than 5 mA between the hot and neutral wires. GFCI receptacles can be used on ungrounded circuits to provide some level of shock protection. However, they do not provide the same level of protection as a properly grounded circuit. Another type of receptacle that can be used on ungrounded circuits is a non-grounding receptacle. These receptacles do not have a ground terminal and are designed to be used in older homes and buildings that do not have grounded wiring. Non-grounding receptacles are less expensive than GFCI receptacles, but they do not provide any shock protection. The NEC permits the use of a non-grounding receptacle as a replacement if the grounding connection does not exist in the box. Also, another allowed method would be to use a GFCI receptacle. It is important to choose the right type of receptacle for the application. If you are not sure which type of receptacle to use, consult with a qualified electrician. When replacing receptacles, it is important to inspect the wiring and electrical box for any damage. Look for cracked or broken wires, loose connections, and damaged electrical boxes. If you find any damage, it is important to repair it before installing the new receptacle. Damaged wiring or electrical boxes can create electrical hazards. If you are not comfortable making repairs, hire a qualified electrician. When working with electricity, it is important to follow all safety precautions. Always turn off the power to the circuit at the breaker panel before beginning any work. Use a non-contact voltage tester to verify that the power is off. Wear appropriate personal protective equipment, such as insulated gloves and eye protection. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. Electricity can be dangerous, and it is important to take precautions to avoid electrical shock. Understanding the National Electrical Code is key to ensuring safety and compliance when working with electrical systems. While the 2017 NEC might not have a dedicated section for replacing receptacles in ungrounded circuits, it's important to know where to find the relevant information. Article 110 covers the general requirements for electrical installations, including replacements. Always refer to this article for guidance. Listed or labeled equipment must be installed and used according to its instructions. This is a fundamental rule that applies to all electrical work. Make sure to follow the manufacturer's guidelines when replacing receptacles, especially in ungrounded circuits. The absence of a ground wire means there's no dedicated path for fault current to flow back to the source. This increases the risk of electrical shock. Exercise extreme caution when working with ungrounded circuits. Replacing a receptacle involves several steps. Firstly, always turn off the power to the circuit at the breaker panel. Secondly, remove the existing faceplate and receptacle. Thirdly, carefully disconnect the wires from the old receptacle. Fourthly, connect the wires to the new receptacle. Fifthly, securely mount the new receptacle in the electrical box. Sixthly, reinstall the faceplate. Seventhly, turn the power back on. Remember to test the new receptacle to ensure it's working correctly. Ground fault circuit interrupters, or GFCIs, can provide enhanced protection. Even though the circuit lacks a ground wire, a GFCI can detect imbalances in current and quickly shut off the power, reducing the risk of electric shock. Installing a GFCI receptacle is a proactive safety measure. Proper wire connections are essential for safety. Use wire connectors that are appropriate for the wire size and type. Make sure the connections are tight and secure to prevent loose connections, which can cause overheating and fires. If you encounter damaged wiring or a deteriorated electrical box, address these issues before installing the new receptacle. Damaged components can compromise safety. Consider consulting a qualified electrician. If you're not comfortable working with electricity, or if you have any doubts about the safety of the installation, it's best to seek professional help. A qualified electrician can ensure that the work is done safely and in compliance with the NEC. Remember, Ungrounded circuits were common in older homes, but they don't offer the same level of safety as grounded circuits. If possible, consider upgrading to grounded circuits to enhance safety. The NEC is a comprehensive set of standards for electrical installations. Staying up to date with the latest edition of the NEC is essential for anyone working with electricity. The NEC provides detailed information on wiring methods, overcurrent protection, grounding, and other important aspects of electrical safety. Always consult the NEC for guidance on electrical work. Working with electricity can be dangerous. Always prioritize safety. Follow all applicable codes and standards. If you have any questions or concerns, consult a qualified electrician. The information provided here is for general guidance only and should not be considered a substitute for professional advice. The NEC provides flexibility in certain situations. For example, when replacing receptacles on ungrounded circuits, the NEC allows for the use of non-grounding receptacles or GFCI receptacles. However, it's important to understand the limitations of each option. Non-grounding receptacles don't provide shock protection, while GFCI receptacles offer enhanced protection. Choose the option that best suits your needs and provides the highest level of safety. Upgrading to grounded circuits is the best way to enhance safety. This involves running a new ground wire from the electrical panel to each receptacle. While this can be a complex and costly project, it's worth it for the added safety. Grounded circuits provide a dedicated path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. Understanding the different types of receptacles is important. Standard receptacles have 2 slots for the hot and neutral wires and a 3rd hole for the ground wire. Non-grounding receptacles have only 2 slots for the hot and neutral wires. GFCI receptacles have 2 slots for the hot and neutral wires and test and reset buttons. Choose the right type of receptacle for the application. Consider the long-term implications of your choices. While it may be tempting to simply replace an old receptacle with a new one of the same type, it's important to consider the long-term implications of your choices. Upgrading to grounded circuits or installing GFCI receptacles can provide enhanced safety and peace of mind. Taking the time to do the job right is always worth it in the end. Remember that electrical codes and regulations can vary depending on the location. Always check with your local building department to ensure that your electrical work complies with all applicable codes and regulations. This will help you avoid costly fines and ensure the safety of your electrical system.